Let's take a look at the Vellum Hair constraint. We can use the Vellum Hair constraint to simulate our Vellum hair. We can simulate the strings, we can simulate the ropes or wires. Let's see how we can create that. I'm going to create a geometry node, and let's dive inside. First we need to create our line. We can either you can draw your own line by adding the curve node. Let's add this, and when the node is selected, press enter, and now you can start drawing your own line, because hair and wire, they will just basically start with this line. I'm going to just use an a line node. Let's add an a line, and let's add this, and that will just create a very straight line. Let's go into the line node. I can adjust the length of my line. I can define the number of points. If I were to enable the point, here you can see I am creating more or less points. Maybe it would be better visualized if I enable the point number. Here you can see I am creating more or less of the divisions of the points, because we are going to create a soft simulation. We need the number of points. We must have some divisions, because if we do not have enough divisions, we will not going to be get a high res bending effect. Let's increase the number of points, and that will just increase the divisions. I'm going to realign the line. Right now we are aligned with the y-axis. I'm going to zero it out, and let's align this onto the z-axis. Now we are at the z-axis. Let's in here create a Vellum constraint node, Vellum hair constraint. We have the Vellum configure hair. Let's add this. It is a Vellum constraint node that is set to Vellum hair. Here you can see the constraint type is set to hair. Now let's add a solver to actually solve this. I'm going to select the node and type the Vellum solver and press shift enter, and that will just connect all of these nodes and set the display flag. Let's hit play, and here you will see that our hair is going to fall. Here you can see it is falling due to the gravity. Let's pin our very first point. If I were to enable the point number, the very first point is always going to be 0, which means I can go into the Vellum hair, and if I find here we have the pin to animation and pin points. I can define the groups. You can create your group that you want to pin, or you can set the point number. In this case, I want to pin my very first point number 0. Let's hit play, and now our very first point has been pinned. And right now our this pin type is set to permanent, and that is why our this second point is also has been pinned. Let's change this to soft. Always use the soft, it will just yield better result. Let's hit play, and here you will see that we will get all of the points moving, and our this point is only anchored to its location. Maybe let's also anchor the very last point as well. In here onto the 0, I'm going to press space and type another point number, and this time I want to also pin the last, which is the 21. Let's type 21, and now both of the points should be pinned, and here as you can see we have this hanging rope type effect. Let me enable my real-time playback, and maybe let's hide the point number and hit play. I can go into my this Vellum constraint, and I can adjust some of the properties of our this material. Right now we have the stretch, and it is set to infinite stretch. If I were to lower down the stretch stiffness, here you will see that our this is going to stretch. Right now I cannot see. Let's maybe lower this value down to 100, or maybe even lower value 1. Let's keep lowering this down 0.01, and here as you can see it is now simulation is now it's just breaking. Let's change this to 0.1, and let's see, and here as you can see we have this springy type motion. And right now, because our pin type is soft, I can change this to stopped, and I think it will not going to move. And here as you can see, and I can lower down this stretch stiffness to 0.01, and let's hit play. And I can go into the Vellum solver. Always increase the number of sub steps if you're facing problems, and that will just increase the accuracy of your overall simulation. I can increase this to 5 sub steps. Let's hit play, And now let's try the pin type. Let's change this to soft again. Let's see if that is stretching, and it is still stretching permanent, and let's hit play. And that's how you can control the stretch stiffness. I'm going to change this back to soft, and let's increase its stretch stiffness. And we have the bend stiffness, and this bend stiffness is what creating this soft behavior. If I were to increase the bend, here you will see this wire is stiff, which means that it is very hard to bend. And it will be better if we have the collider in here, and that will visualize it better. Maybe let's create a collider, and I'm going to create a sphere in here to create the collider polygonal sphere. Let's add a vellum constraint. I'm going to create a vellum shape match constraint to create the rigid constraint. Let's change this to shape match, and we need to merge both of them. I'm going to add a vellum pack node, or just simply add these two merge node. I'm going to merge this geometry, and order is important. And right now here as you can see, I am using this reverse order. And if you were to add another merge and order your constraint first, this constraint first, and this constraint first, here you will see that our simulation will going to break. And I'm going to go into this sphere, and let's move the center, and let's also adjust its Z offset so that we have at the center. I'm going to also lower down this size, and if you hit play, here you will see that our simulation is breaking, and that is because of the order. It must be in the same order as you have the geometry. Right now we are using this first geometry and this, and then the vellum constraint, these constraint in that order. We need to go into the merge, and let's click on it. And now we have organized the order. And now if I were to hit play, our simulation will work just fine. And here as you can see, and right now it is stretching because we have a very heavy object. And let's hit rewind and hit play, and here as you can see, it is a very stiff looking hair. I can go into the vellum hair, and I can go into the bend. Let's lower down its stiffness to 0.01, and here you will see that it is going to be a very softer. And now it is just stretching a lot. And here as you can see, I can create another example in here, and for this one I'm just not going to use all of these, or maybe just duplicate all of these setups onto this side. And let's remove that and remove this merge. I'm not going to use the vellum shape match. Let's connect this. Let's copy the hairs onto this sphere. And for copying this, I'm not going to use these original points, because later on I'm going to add a copy to points node. If I were to add copy to points, as you know, it requires the points, and I don't want to use these original points. I'm going to just add a scatter node, and I'm going to just scatter a bunch of points. Let's go into the scatter, and let's lower down the number of points. I don't want that many copies of my hair. Let's organize this node graph. And that is the geometry I want to copy, and that is the scattered points. And right now they are not aligned because we do not have normal. So let's add a normal in here by using the normal node. Let's connect this, and now the copy to point node will going to align our line to the normals. Let's go into our vellum hair, and that is our vellum hair geometry. Let's go into the vellum solver. Let's hit play, and here as you can see, our simulation is falling. And right now the very first point has been pinned because pin to animation is turned on. I'm going to let's remove this, and here as you can see, all of our hairs are falling due to the gravity. Let's pin our hair to this collider. Right now we are using this sphere. Let's pin this to the collider. First we need to add this into our simulation as a collider. The last is for the collision. Let's connect this now that we have the sphere in, as a collider and it will collide, and some of the hairs that are actually inside of the collider, they got trapped, and that is why we have this hanging effect. If I were to, let's say, scale down my sphere by adding the transform node, transform this, and let's scale this down. Were to lower this uniform scale just slightly and hit play, and here you can see we have all of our hair falling. And right now the scaling, here you can see the scaling is not happening at the correct pivot, because the pivot is set to default at the 0 0. And to actually center out the pivot location of the transform node, we need to collapse this pivot transform option, and we have the option move pivot to the centroid. Let's click on it, and it will just going to center out the pivot onto our this geometry, which means if I were to transform this, now we are transforming this at the geometry origin, at its geometry center, and now we have the scaling happening correctly. Now if I were to hit play, here you can see all of our hairs are falling, and that was the point I want to make, that they are not actually connected because they are trapped inside. Some of them are trapped inside, that is why they got just trapped and they are not falling, but they are not attached to it. Let's fix that. Let's attach these points, and to actually attach this, we have a constraint vellum attach. Let's type vellum attach to geometry. Let's add this in between, and what this vellum attach will do, it will going to look for the collision geometry, and right now we have the collision geometry present. And if I were to view the vellum attach, and here you can see we have these constraints visualized, all of these, which mean that all of the points are attached to our this collision geometry, and I don't want that. I only want to attach this very first point to the collision. And to fix that, let's go into the vellum attach, and let's enable the max distance option. Let's enable this, and which means that we can define the distance. Let's continue increasing this, and here you can see as I continue to increase its value, if I were to maybe add bigger increment, here you can see I am attaching more and more points to our this sphere. But I'm going to just add a slight, maybe let's increase this to 0.03 value, and here you can see all of my points are now being attached into my collision geometry, which means if I go into the vellum solver and hit play, and here you will see my hair has been attached, and I can increase the resolution. Let's go into the line, let's add more points so that we have a better high res mesh, and we can also animate our collider. Right now we do not have any animation. Let's go into the transform, and let's animate this onto maybe z-axis like so. I can add a key at the very first frame. Let's start with 0, and here you can see as I'm scrubbing, we are also simulating. So let's disable the solver. I don't want the simulation to be happening when I'm scrubbing. Let's go a few frames forward, and let's adjust its setting. Maybe let's add a positive value, add a key. Let's go a few frames forward, and let's change this to minus some value. Let's add another key, go a few frames forward, and let's make this to the default and add another key. Let's go into the vellum solver again. We are at the vellum solver. Let's enable the vellum solver, enable the simulation network. Let's hit play, and here you can see all of our hair are now following the animation of our collider because they are attached to it. I can even add the rotation. Right now we do not have an rotation. Let's go into the transform, and I can also animate the rotation, or maybe we can add the expression. I can add a $f. $f mean the current frame number, which means that we are adding the frame number in here. And if I were to hit click, here you can see we are actually inserting our current frame number into the rotation. And now we should see the rotation happening. Right now not quite a lot of rotation is happening, so let's multiply this. Let's click on it so that we have the expression, and I'm going to multiply this by 5. Let's say I want to create a 5 time more rotation, and here you will see we should get the rotation. Let's come this into the rest, and we will going to be seeing the rotation. And here as you can see, all of our hair are also rotating, and they are attached to our collider. I can now go back, and that is our geometry. And to add the thickness in here, we can add a polywire node, and that will just add the thickness. Let's connect this and view the polywire, and I can go into the polywire and let's lower down the radius. And to actually smooth out, right now we are creating the square ribbons. I can go into the divisions. Right now we are using 4 sides. Let's continue increasing this to smooth out these ribbons. And if we hit play, and here you can see we have these very thick hair back. And that is the basic of Vellum hair constraints.